chromosome 19. And again, you see a very similar pattern of the fox-like canids possessing this evolutionary breakpoint here. What's interesting about this chromosome panel is that within the South American canids, the panel lies on the same chromosome. However, for two of the species, they actually include a new centromere. So these two sections, instead of having a break across two different chromosomes, they actually have a breakpoint in the same structure. However, these lie on opposite sides of a centromere. And so when examining the phylogenetic tree, so here, these are the fox-like canids, which correspond to these species. You will see that there is a pattern here of the two sections of chromosome 19 being preserved in the fox-like canids, and in the wolf-like canids, including dog, they had a fusion event to organize chromosome 19 as one structure. So with these data, you're actually able to summarize or determine the different karyotypic changes in the canids. You're able to track this this karyotypic restructuring with the phylogenetic tree. What was interesting with our data was that we found that the bat-eared fox evolutionary breakpoint patterns actually don't match up with the phylogenetic tree. Instead, their patterns match more closely the Chinese and Japanese raccoon dogs. So we proposed a change in the phylogenetic tree that moved the bat-eared fox closer to these two species. And this is the summary of that. And this has been incorporated into further phylogenetic trees. So it really exemplifies the fact that cytogenetic data do improve the phylogenetic trees. And that species especially has been a problematic phylogenetic grouping. So in previous phylogenetic trees, that species kind of is placed in different places. And so as a summary, the final point about whether these evolutionary breakpoints overlap with breakpoints with regions of instability in cancer, the same region on chromosome 19 is found to be a region of instability for several canine cancers. The majority of our lab studies canine cancers, and so I was able to compare this region with the dog canine cancers and find that lymphomas, leukemias, a type of osteosarcoma, and hemangiosarcomas do contain regions of instability that correspond with this evolutionary breakpoint. And this is consistent with the fragile breakage model, or with the breakpoint reuse theory.